You start with 120 milliliters of a 2 molar solution of sodium hydroxide, and you want to dilute it down to 0.25 molar solution to use in lab. What is your final volume? So to start with this dilution problem, I need to find out my starting solution and ending solution, concentration and volume. So for my starting solution, I know I have a volume of 120 milliliters and a concentration of 2 molars of sodium hydroxide. For my final concentration, I have a volume. I don't know the volume. So that is what I want to find out. But I do know the concentration, and I have 0.25 molars for the final. So using this, how do I find this, the final volume? Use M1V1 equals M2V2. 1V1 equals M2V2. So this would be M1V1. This is M2, and now we want to find V2. So I do a little math, and I set up the equation like this. To save time, I can move the M2 over here. So I have our V2, and that will be equal to 120 milliliters times 2 molar over 0.25 molar. So the first thing I can do is cross out the molar, so I know all I'm going to be left with is milliliters, which is volume. So after I plug this into a calculator, I get V2 is equal to 960 milliliters. So we started with 120 milliliters of a concentrated solution. So we're expecting this to go up, and our volume did go up, and it went up about 4 times as much, or actually 8 times as much. But if you can eyeball it, you can kind of see how much it's going to go up, but you don't always get exact molar concentrations like 2 and 0.25 molar. But this is the basic setup for doing a dilution problem. So you end up making a 110 milliliter 0.15 molar sodium hydroxide solution in class. You started with 15 milliliters of the sodium hydroxide solution, but you forgot to record the initial concentration. Is it possible to figure out the concentration you started with before the teacher finds out? All right, well, we better hurry. So this is a dilution problem, but you're kind of going backwards this time. So first, let's write down everything we know. We know we had a volume. Well, we ended up making a volume of 110. So our final volume was 110 milliliters, and we made a concentration of 0.15 molar. And we know we started with 15 milliliters. So what we need to find out, though, is our initial concentration. That we do not know. So again, this is M1V1, but backwards, but it still ends up being essentially the same thing. So the M1V1 equals M2V2. Can plug in everything but M1. So I move M1 or I move V1 over. I have M2 V1, which is going to end up equaling 110 milliliters times 0.15 molar is divided by 15 milliliters. And cancel out the milliliters. All I'm left with is this is supposed to be an M. Okay, that was actually worse. I'll just do this. Yeah, sure. Now it's an M. A very badly drawn M, but it's okay. We'll get to the next part soon. So now we just plug this into our calculator. So after plugging this into our calculator, we realize that we have M1, which equals 1.1, and the units I'm going to use are the molar, because I canceled out the milliliters. So I figure out, oh, when in the very beginning I started with 1.1 molar solution that I had 15 milliliters of. And this makes sense because when I dilute the solution, the concentration is going to go down. And that is what happened here. I started with 1.1 and it went down to 0.15 molars. Yeah, so now that we have our initial concentration that we knew all along, we go back and write that 1.1 molar in our notebook in the very beginning. So when the teacher walks by, he is none the wiser, and we're good to go. Now let's try an example in industry. So you work at a pharmaceutical company that is analyzing their new drug, diazepam. Your coworker gives you a stock solution of diazepam at 500 mg per mil. She prepped it in a 250 ml volumetric flask. She hands you an empty 250 ml volumetric flask and tells you to prep a working standard with a 10x dilution. You nod your head and tell her, no problem. As she walks away, you scream on the inside and try to figure out how to perform this dilution. Okay, so here we have another dilution problem, and let's see how we can solve this one. So let's write down all the information we have. We know our initial volume here is 250 milliliters, and our initial concentration is 500 mgs per mil, and she wants a 10x dilution. So what does that mean? Well, she wants us to dilute it to 50 mgs per mil. So, all right. So now I know, oh, I just plug all these in, solve for V2, and then, oh, wait a minute. She gave us a flask already, 250 mil volumetric flask. That means we have a V2 already of 250 milliliters. And this kind of makes sense because if we diluted this from a 10x, this would be 2.5 liters. That would be massive walking around with these volumetric flasks, and we'd be wasting a lot of chemicals that cost a lot of money. So we can't just do our typical M1V1. So she starts with this 250 milliliter for V2. So now we got to realize, okay, we got to solve for what? So looking at this problem, what can we change? Well, the concentration went from 500 to 50, so this seems right, but our volume goes from 250 to 250. Okay, so something with the volume has to change. But what? how do we do this? Well, we know we have to have 250 milliliters for our final volume. And because of that, then somehow this right here, the V1, this needs to change. So trying to figure that out, that means, oh, this is what we need to solve for. So we just do M1 V1 equals M2 V2. This again, move over the M1, and then I plug in the numbers, so I have 50 megs per mil, and that's times 250, and divided by 500. Well, this is 250 milliliters, and this is 500 megs per mil. So again, let's do out some math. So when I'm doing out the math, I cross out the megs per mil. All I'm left with is milliliters now, so it's good. I know all I have is milliliters. And then I just plug in the math problem into your calculator. So I have V1 equals 50 times 250, and then divided by 500. And when I plug into my calculator, I get 25 milliliters. So V1 equals 25 milliliters. So what does this answer mean, 25 milliliters? Well, so since our V1 is 25 milliliters, that means my stock solution, I have a 250 ml volumetric flask. I'm only going to take 25 milliliters out of that volumetric flask, and I'm going to put it into the new volumetric flask. And then whatever the solvent is, it could be some other chemical like IPA, I just bring that up to volume. So that means I have that 25 mils of this 500 mg per mil solution is put in this container, and then I just dilute it with some other chemical until it gets to 50 mg per mil. And I can do that by getting to 250 mils. This is a very common technique that you'll see in industry, because we can't just do our typical dilutions, because if we diluted this normally, we would have had a much bigger amount for V2, and we'd be wasting a lot of chemicals. And the one thing your company does not want you to do is waste lots and lots of chemicals. So one, you save money by doing this. Two, it's also just easier for you. You just don't have to pour a lot of stuff. You just take a smaller amount out. Like, this doesn't have. I've a lot of times used 250 in industry, but sometimes you could use 200, 100, even 50 or 10 milliliters volumetric flasks. It is really, this actually gives you a lot of freedom to do it however you want to do it, but it also kind of depends on what other supplies you have. You have to have the right pipettes. Sometimes if you only have large pipettes, it makes it easier just to do a bigger one. But if you have like very, very small ones, it can be good. But then sometimes the small ones, you have to weigh out a very small sample, which can actually be pretty difficult getting it exactly correct. And it ends up kind of becoming up to like what works for you. But also in industry, most likely you're going to be following what's called like an SOP, a standard operating procedure. So they essentially have everything you're going to follow, and they'll have instructions on how to do this. But it's good to know how to do this on your own, just in case you wanted to do this on your own, or um, you don't have to read the document every single time you do the experiment. You kind of understand what is going on. So it's better to have a deeper understanding when you're thrown in industry and not just have to rely on the document to follow. But this is stuff that I have done in industry, and most likely, if you join industry as well, a pharmaceutical company, you will end up doing dilutions like this as well. And just a quick explanation, stock standard is your very, very concentrated standard solution. And this usually is something that in industry you'll be able to save for like a week, a month, a couple months. So you prep it like this, and then every time you run the experiment, you prep what's called like a working standard. This is the standard you're going to run on the instrument, like a GC or LC. And every time you run it's going to be too concentrated at whatever the stock solution is. So you want to dilute it to something that's better suited for the instrument. So every now and then I'll just take out 25 mils and then put it into a new volumetric flask, and then I have 50 mg per mil, and I can run my experiment and test whatever I need to do for the experiment. Now, in case you don't know, a volumetric flask is just like a flask that is kind of already pre-measured. It kind of will look something like this. For some reason, I can't do a straight line. Sure. And then there's going to be a little line at the top. And so when you fill up whatever chemicals you have in here, like we fill up the diazepam to like right here, and then we dilute it with whatever other chemical, and we just keep adding it, and we just get right up to the line, and then we do something called QS, which all you have to know is we just basically want to get it exactly to, we want the meniscus to be exactly on the line, and that's a standard way of measuring. And that way we know we have like the exact amount every single time, and it's very accurate. So you'll be using a lot of volumetric flask in industry most likely. I hope you liked my video on dilutions, and I hope you like my industry example as well. Please leave your questions and comments below, and like and subscribe. Thank you.